Hello, college algebra student. This video is for chapter 2.7 part 2. We continue with the discussion of linear and absolute value inequality. And we went over how to solve linear inequality that consists of compound inequality, more than one. And also the answer would be like in two parts. We can use interval notation to document the values or the answers. So rather than giving the inequality answer, we also give a number line and as well as a interval notation. So we work on the first one, which is in between inequality, when we have the unknown in the middle, and it is between, or actually an expression consisting of unknown in the middle, and then a low number and a high number. So in this case, the inequality is similar, but it's reversed. We have the low number on the right side and the high number on the left side. Also, we have a greater than in the left-hand side and the greater than equal to. So this is just a little change from what we have in the last example. So let's see how we solve it. We can still see it as in between 5x minus 2 is in between two numbers, except that our low number is on the left hand and the right hand side. So we use the same idea of solving three column portion of inequality, and we say our goal is to have x in between, because that's what we want to solve. So to do that, we would eliminate the minus 2 by adding 2 on all three columns. Because if this is a true statement, then if you add 2 on all three columns, it's still true. So I have 10 greater than 5x greater than equal to 5. And then in order to have x in between, I will divide it by 5, divided by 5, divided by 5. So T2 would be in between x, in between 1. Okay, so let's switch it back so that the left-hand side has a low number. So 1 is less than equal to x and is less than equal to 2. So you can read it as, this is strictly less than. Let's say erase it, because this flip over should be just say less than. And then we can draw the number line. The number line would be x is from 1 to 2, including 1, but not including 2. So when we write the interval notation, it would be a square bracket 1, and then a open bracket of 2, not including 2. But this kind of inequality is kind of rare. Okay, it does show up in our textbook. So the last things, we have one more example which include OR. So OR inequality is a compound inequality that say the answer would belongs to either this or this. So at the end, we'll combine what we solve together to give the answer. So we'll solve each of them individually. So solve this 3x plus 1 less than negative 3 will be minus 1, minus 1. So 3x is less than negative 4. X is less than negative 4 over 3, because I will divide it by 3 over here. And on this side, we'll just keep on saying OR, keep on saying OR. So it is not the English OR saying that your teachers tell you you can do this or this. No, you have to do both of them. But the answer would include x that satisfy either one of them. So plus 5 plus 5. So 2x is greater than equal to 6. X is greater than equal to 3. So we have the answer would be all the x that would satisfy either one of them. So we'll just graph all of them. X is less than negative 4 over 3. So if x is 0 over here, negative 1, negative 4 over 3 would be a little less than 1. On this side, should be an open bracket, because not including that. And then this is greater than equal to 3. So 1, 2, 3, but it's solid dot and like that. So I highlight all of this because or means either one of them is fine. So now in interval notation, we'll say this is negative infinity up to negative 4 over 3. And this would be open union. We would use a square bracket because it is including 3 from 3 to infinity. So that's the answer. When you do OR, that's how you do it. The last part of 2.7 is solve absolute inequality. We have learned that absolute value is used to describe distance, right? If I have something, say like x is less than 5, that means the distance of the number of x to 0 are less than 5. So I would think that are between here. So all these values has a distance to 0 less than 5. So whenever you see an absolute inequality, you think of distance to 0. How far away they are to 0. And if it is less than, that means they're in between here. For x is greater than 5, this would include number that are very far away from 0, so that the distance to 0 is more than 5. It would be these two sides, right? Outside of 5 and negative 5. So anything you see a distance greater than, it would be on 2n. Any time you see a inequality or absolute inequality of less than, that would be in between. Only if you are talking about absolute, because that means distance. So likewise, if I don't have x in between, but ax plus b less than c, where c is a positive because it could be a distance, that means less than, just like here, less than is in between. So it would be equivalent to ax plus b, this variable's distance to 0 is between negative c to c. And if you see an inequality that include absolute value of ax plus b greater than c, where c is positive, then you're thinking of two sides. These numbers are very far away from 0, greater than c. So you can think of, oh, I have a negative c, I have a c, but these numbers, ax plus b, distance to 0 is at the 2n. So that's why I would have ax plus b is greater than c, right? This is greater than c, and ax plus b is less than or equal to negative c is on this side. So if you are to solve an absolute inequality, you're thinking of the number line, either in the middle or on a 2n. And if your c is less than 0, then and for an inequality of absolute value ax plus b at distance less than 0 or less than a negative number is not possible, right? Because at distance, the lowest number, it could be 0. It's always positive. So it has no solution. But if they say ax plus b at distance is greater than a negative number, that's always true. That's always true because the distance is a positive or a 0 number. So it has all real number solution. So when you solve this kind of absolute inequality, watch out for the right hand side, what the other number is. If the other number is a negative number, you don't have to solve it. You just have to look out if it is a no solution or real number. Let's solve the first one. I have x minus x is greater than 4. What do you think? Greater than 4 means these numbers is at the two end, negative 4 and 4. So you would write it using OR. We'll write it using OR. So you would write x minus 8 is greater than 4, or x minus 8 is less than negative 4. See how this is less than negative 4 and this is greater than 4. So in other words, you strip off the absolute value, copy it over, and then you strip off the absolute value but switch the greater than to less than and then switch the sign like this. So in a nutshell, you can do it that way. Let's solve it. So plus 8, x is less than 14, or, oh no, 12, or plus 8, x is less than 4. So if I draw the number line, this would correspond to greater than 12, less than 4. And these are all non-including the endpoint. So my answer is negative infinity or union 12 infinity or open bracket. The next one is 3x plus 4 minus 2 less than or equal to 3. So is it less than? Should I just do negative 3 and 3? Not yet. We have to isolate the absolute value first. So before you do the breakdown of like you in between or, you should clean up everything outside of the inequality first. So plus 2. So my absolute inequality should be 3x plus 4 less than equal to, actually this is 2, 5, less than equal to 5. So less than equal to means the distance is shorter than 5. So that means it's between 5 and negative 5. So I rewrite this as, because we can't actually break up this absolute inequality, we have to rewrite it as negative 5 and 5. Now this become a 3-column inequality. So minus 4, minus 4, minus 4. On all 3 columns, this become negative 9 less than 3x less than 1. Divide by 3, so negative 3 divided by x less than 1/3. So this is the answer. So it's in between negative 3 to 1/3. Oh, and actually there is a equal, right? So it's equal, 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 equal. So I should have solid dot, and it's between that. So the answer would be negative 3. Including this, I use square bracket. 1/3, I use square bracket. The last one. It is 2x minus 1 greater than negative 1. So all the number outside has been cleaned up, but I'm ready to do, but I notice that this side is negative. When absolute value is greater than negative number, it is always true. So I don't have to solve it. When it is always true, that means whatever xi, the solution is all real number. I do not have to solve it. No matter what number I put in, it would always work. Solution is everything on the number line, so negative infinity to infinity. Whereas this one, 5x minus 2, is less than negative 3. So this is a distance. This distance must be positive, must be greater than or equal to 0. So it cannot be less than negative 3. So it's not true at all. Any x you plug in, they will never hit a number that's less than negative 3 because it's a distance. So no solution. So that's the end of 2.7.